Hey everyone, so today we're going to be talking about a new topic, and it's going to be the Pythagorean Theorem. You might have seen this in middle school. If not, don't worry about it. We're going to start with the basics. But this is a really important theorem for geometry and in algebra too, so make sure you're paying close attention and taking good notes. All right, so the first thing we want to talk about is what is a right triangle. A right triangle is a triangle that contains a right angle, which is 90 degrees, and two acute angles. So acute angles are angles in between 0 and 90. So an example would be like 30 degrees, 60 degrees, 45 degrees. Those are all acute angles. So here's our diagram. We have our triangle. It has three sides. This 90-degree angle is always represented by this little square here. And then we have two acute angles. We can see that they're smaller than 90. And then this has one arc and this has two. That is something you're going to see a lot in geometry. And it's just to represent that they're not the same measure. They could be the same measure in other examples. You know, we could have 90, 45, and 45. But in this case, we're just showing that they're acute and they don't necessarily have to be the same. Okay, so parts of a right triangle. So here we have our right triangle. We know that it's a right triangle because it has this 90-degree angle right here, this right angle. And this is an important word, hypotenuse. The hypotenuse is the longest side of a right triangle. It is always opposite the right angle. So you're going to see me drawing a lot of arrows. That's because it's really important to identify your hypotenuse early. Okay, and a really easy way to do that is just draw an arrow from your right angle, and that's your hypotenuse. The other two sides of the triangle are called legs. So they both have the same name. Doesn't matter which one's which. We have our two legs and our hypotenuse. So the Pythagorean theorem, we only use it with right triangles, so that's really, really important. And it is a formula used to find the missing lengths of a side of a right triangle when the lengths of the other two are known. So if you are given two lengths of a right triangle, two sides, to find the missing side, you're going to use the Pythagorean theorem. Now, sometimes the hypotenuse is going to be missing, and sometimes one of the legs is going to be missing. And we're going to see examples of both, and you're going to use the same theorem in both of them. You just have to substitute correctly. And it'll make more sense when we go through a couple examples. But this is the Pythagorean theorem. A squared plus b squared equals c squared, where a and b are the legs, and c is the hypotenuse. Now, it does not matter which one we call a or b. Basically, it's just a leg squared plus a leg squared is equal to the hypotenuse squared. So for this diagram, I labeled this a and b here, but it really could be a is here, b is here. It doesn't matter. Just as long as we know that c is the hypotenuse. The hypotenuse is always going to be what it's equal to squared. Pythagorean triples. This is a set of three positive integers that satisfy the Pythagorean theorem. So here's a list, and the list goes on and on. So this is just a few. These are all numbers where if we were to take these three numbers and plug them in for a, b, and c into the Pythagorean theorem, they're going to work every single time. So like we said before, the hypotenuse is the longest side of the right triangle. So that means it's always going to be the largest measure. So we see here that they're in size order, 3, 4, 5. That last number, the biggest number, is always going to be the hypotenuse, and then the first two are always going to be the legs. So in order to identify a Pythagorean triple, they have to be in size order. Now, you can multiply each set of these numbers by the same number to create another triple. So here we have 3, 4, 5, and here we have 6, 8, 10. If you notice, this triple is just this triple times 2. 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. So whatever number you want to multiply the triple by, that creates another Pythagorean triple. So say we wanted to multiply it by 3. Then we would have 9, 12, 15. That's Pythagorean triple. Okay, so this list can go on and on because we can multiply each of these by a constant. All right, so let's look at an example. Here it says, find the length of the third side. If necessary, round to the nearest tenth. Step 1, identify and label the triangle's legs and hypotenuse. So we're going to identify and label A, B, and C. The first thing I'm going to do is I'm going to draw my arrow from my right angle to identify my hypotenuse. So in this case, it's X. I'm just going to put a C there in a circle. So I know that this is my hypotenuse. Now, like we said before, it doesn't matter which one's A and which one's B, because addition is commutative, so the order of those don't matter. So I'm going to just call this one A. Let me just make it look pretty. We're going to call this A. We're going to call this one B. Remember, it doesn't matter. You can say that the 9 is A and the 12 is B, but either way, it's not going to matter as long as X is our hypotenuse here, C. Now from there, we're going to substitute it into the Pythagorean theorem. So I'm going to just rewrite it at the top. A squared plus B squared equals C squared. And I'm going to just take the numbers and the variables that I have from this example and substitute it into my equation. So A is equal to 12 here. So I'm going to write 12 squared plus, now B is equal to 9. So instead of writing B, I'm going to write 9. Get 9 squared equals C squared. And in this case, the C is X. We don't know what that is. That's the unknown. So we're going to try to find that. So that is X squared. So all I did was identify A, B, and C, plug it into the Pythagorean theorem. Now from there, we're going to solve this equation, and then we're either going to leave it in simplified radical form, it could be a whole number, or we're going to round to the nearest tenth depending on the question. So 12 squared, 12 times 12 is 144, plus 9 squared is 81, 9 times 9. And then we don't know what X is, so I'm going to leave it as X squared. Now from here, we're going to combine. 144 plus 81 gives us 225. I'm going to just bring down that equals X squared. If you want to draw your train tracks here, where you draw your lines to stay organized, that's fine. So now the goal is to get the X by itself. The X is not by itself because it still has this squared here. So hopefully you remember the opposite of squaring something is finding the square root. So what we do to one side of the equal sign, we have to do the other. So to get rid of this squared, we're going to have to square root both sides of this equation. When we do that, the square root and the squared cancel out. So we're just left with X. That's the whole point of this. We want to get rid of that squared. We want the X to be by itself. So to cancel that out, you have to square root both sides. Now, the square root of 225, luckily 225 is a perfect square. The square root of 225 is just 15. So we don't need to round. We don't need to simplify our radical here. So all we are left with is X equals 15. So this hypotenuse is 15. Hopefully you noticed also I kind of gave you the answer on the last slide because this is a Pythagorean triple. And we talked about if we were to take 3, 4, 5 and multiply it by 3, we would get 9, 12, 15. 9, 12, 15. So this is just an example of a Pythagorean triple multiplied by 3. All right, let's take a look at one more example. Find the length of the third side. If necessary, round to the nearest tenth. So we're going to follow those same steps. Hopefully you have them written down in your notebook so you can easily go back and use them as a resource. So the first thing we want to do is identify our legs and our hypotenuse. Hypotenuse first, because that's probably the most important one. I mean, they're all important, but draw your arrow from your right angle so you know that this is our hypotenuse. So I'm going to just put a C there. So this 10 is C. And then it doesn't matter which one goes which. I'm going to put A here and B here. So our missing side is this A. We don't know what A is. We know what B is, and we know what C is. So I'm going to rewrite my Pythagorean theorem. A squared plus B squared equals C squared. And I'm going to plug in what we know. So we don't know what A is, right? There's nothing next to the A. There's nothing on this side. So I'm going to just bring down that A squared. I don't know what it is. I know what B is, so we're going to, instead of writing B, we're going to write 5. So 5 squared equals, and instead of writing C squared, we know that C is equal to 10. That's our hypotenuse. So we're going to get 10 squared. Now we're just going to simplify from there. A squared plus 5 squared is 25. And then 10 squared is 100. 10 times 10. And then we're going to solve it like we would a regular linear equation. We want to get the A by itself, so we're going to subtract 25 on both sides. That's going to cancel. Bring down your A squared. And that's going to equal 100 minus 25 is 75. Now we're going to do the same thing where we want to get the A by itself, so we don't want the squared next to it. So in order to do that, we are going to square root both sides of this equation. So then the square root and the square cancel out, and we're left with A equals the square root of 75. Now remember, our question said round to the nearest tenth. So that means we're going to take out our calculators, and we're going to find the square root of 75. So when you plug it into the calculator, you're going to get 8.66025, and so on. It's going to keep going. It's an irrational number. And we want to round to the nearest tenth. So the number in the tenths place here is 6. We always look at the number to the right. And that's going to tell us if it's going to go up or stay the same. So remember, 5 or more, raise the score. 4 or less, let it rest. Now 6 is greater than 5. So that's telling us that this 6 in the tenths place is going to go up to 7. So we're left with A equals 8.7. And that's our answer. I don't know why it always does that. That's a point. Okay. So just to summarize, the first thing that we're going to do is identify our A, B, and C. Start with your C first, because then A and B don't really, either one could be A or B, but C is the most important one because only one side can be C. Then you're going to substitute into your Pythagorean theorem. Like I said, sometimes you're going to be finding the hypotenuse like we did in the last example. Sometimes you're going to be finding a leg in this example. So making sure that you identify these and plug them in the right spot is really, really important. And then you just solve from there, and just remembering that to get rid of the squared, you're going to have to find the square root of both sides of this equation. Good luck.